Hello guys. So I'm back with another tutorial that I promised to share last year, and well, I had a task on my day job. So let's say we have a vehicle and it was a part of the R&D project, and we need the ability to add procedural participation on a vehicle. And we have some limitations, like we use the night, and as far as I remember, even till now, if you use the night, you cannot dynamically change the vertex data through the shader. So we could also use the render targets to paint over the meshes. I used these methods on my previous tutorial, but it requires to store a lot of data for each actor, and it needs some more lightweight technology. So I came up with a simple idea which can actually fulfill nearly 90% of requirements, and I'm going to share it with you. So let's start it. So first of all, about the feature. Here's a little diagram or a picture that I'm going to use to explain how the thing works. So we're going to have an actor component, dynamic interaction component that we're going to add to our pawn. So I used the vehicle sample project for the demonstration, and we're gonna add it like here. That's it. This component itself, I'm gonna trace like this over the mesh or a landscape and receive some data. And we're gonna use this data and, as you can see, physical material to specify the layer ID over which our vehicle is gonna be running. For each vehicle part, as it can be made of several pieces, in this example we have only one, this one, skeletal mesh. We're gonna use tag. Mine is called dynamic interaction, and we need to tag all of those pieces so we can apply the shader magic to those meshes without using the direct material references, just by using the custom primitive data. So as you can see, we have added one, and it already has 13 different layers. Each index here gonna represent the layer ID and the layer intensity. So as you can see, 0 is mud, 1 is puddle, second one is, or the third one is snow, and over the tens we have the mud intensity, pud intensity, and snow intensity. So like 0, 0, 1, 1, 2, 2, so they are in such correlation. Here you can see the flow. So we have the ground. It's gonna have one material. I'm gonna use the landscape so I can define the layers and I can mix them up and have some advanced shader logic, not just by using the mesh. And on this ground we can add like a lot of different layers. In my example, we have 3, like mud, snow, and water, and in some cases they are overlapping, like here and here, and so on. We have a car which, if it drives on the simple ground, it won't gonna have any participation applied. But once we are over the mud, over the time we're gonna add the mud mask. So as you can see, we can store up to 3 layers. As far as I tested, but probably we can move up to more of them, but you can only have like one active. So if we have, like here in the example, we drive over the mud, we have some mud, now we need to drive over the snow. We're gonna add snow layer over the one that we have underneath, until we're gonna cover our car with a lot of snow but without the mud. Or maybe we can see some of them, because the pattern we define is not the whole coverage, but we like define the amount of the mask we're gonna apply for each layer. Sorry. Then we move to the water, and we now can see that we have only 2 layers, because snow gonna be covering a lot of our, like a lot of shape of our car, volume of our car. And then once we are on the water, we're gonna remove the previous layers, and once we're gonna drive over the ground, we're gonna remove all our participation layers. So each layer, as you can see, can store its intensity, and here in the component, you may see I have a lot of different variables. We have the layer map. So here you may see that we have like the physical material and the integer, and each integer here represents the particular layer, like mud, puddle, and snow. And we have the layer intensity map. So we're gonna fulfill it with the data, where the index that we have from the layer map gonna be the index with the intensity. It's a float for this map, so we can know, like, if we drive over several layers, how much data we need to store for each layer. So I honestly think that my explanation isn't too confusing for you, and I had pretty much big break or like the vacation, so it's hard for me to say complex stuff in simple way. Next one, once we stop and we not gonna move, we have a sort of a timer after which we're gonna clear all our participation. You can define it like here, and the time can be changed. Also, once we start driving over the one layer, we're gonna accumulate the intensity, but once we stopped, so I have a function is standing, which returns the condition whether our velocity is equal 0 or not. We're gonna stop accumulating our intensity and store it until we're gonna move. That's how it works. And you may see also that the pattern generated randomly. So here under the layer base, layer pattern, here we're gonna use the noise, right? It's the procedural node. You can use the texture array and simply with a seed define which index of the array you're gonna have for your noise pattern, for your noise texture to use. But I have, like, as I said, it was the R&D project. A different approach where with the custom HLSL code, like pseudo-random X, depending on the seed, we can generate different pattern. Each time we're gonna update this seed index. We're gonna use it here in the blueprint. under the function called generate new pattern. I'm gonna show it to you, but it's just for you to understand the logic, how everything works. So I guess that's it. You saw the demonstration, and I'm gonna share this project via my Patreon, so you can like acquire it. It's gonna be the tier 1 and tier 2. So yep, now let's move up to the logic. So we're gonna start with the simple things first. So here you may see I have the layer base material function, and we have the input of vector 3. You may have more complex logic, it's just for the sake of the demo. Next I have 3 more different layers, and those layers are actual material functions. I have a reference from the layer base with the predefined color for each layer. So we have the representation of a mud, of a water, and of a snow. And here you may see I have a landscape with the material applied over it. And on the left you may see that I have 3 different layers. So we need to press on the plus button and create the layer info. And we have like mud, puddle, and snow landscape layers. We also have 3 different material, physical materials, like mud, puddle, and snow, and we use those physical materials as a reference for each landscape layer in such correlation, like mud, mud, puddle, puddle, snow, snow. We need to have this stuff so we can use it in the actor component to specify the layer ID over which we are driving to correctly apply paint with the specific intensity. In the landscape layer, landscape material, I have landscape layer blend node, and I provide those material functions as the inputs for each layer. Layers are white blend, and that's actually it. That's the basic setup. Now we have the layer pattern. It's another material function. Here we need to calculate the pattern for our mask to apply over our car. So for this I use the world position, subtract over the object position of our car. Then I transform the world space to the local space and add a value. This value is generated with the custom HLSL code. The code itself looks like this: pseudo random x in brackets. Each input here has different multiplication, so we have different values for each output for each custom node, and they also multiplied by 100 because we're going to use here the world position to the procedural noise, and we need to define that the seed that we have here, the position, gonna be different for each pattern, so the pattern won't look similar each time we generate it. Noise here have different attributes, and it's up to you to define the look of your pattern. Next, we need to subtract from the mask intensity this mask, because it's gonna be the black and white gradient. Here, use the round node to have the sharp and crisp edge for my mask pattern. So that's how it looks by default. You may see that I have crisp, sharp edges, but if I just remove the round here, my pattern will look kinda blurry. Yep, you may see it. So it's up to you to define the art style of your patterns. And we're gonna use this layer pattern material function in the vehicle material. So that's my vehicle material. I have the texture input for the normal map and the albedo, and I'm gonna also only change the final color because I only have the overpaint with such stuff because it's like the demo. The logic is kind of simple as it follows from the flow. So mud, snow, water. You define the order by yourself. So let me check my component, my layer map. So mud, puddle, snow, 0, 1, 2. And the vehicle base, mud, puddle, snow, 0, 1, 2. Yep. So the way you organize your logic in shader here should be the similar to your to the layout that you have in your actor component. So those indexes should be the same way set. And we use the reference for our layer pattern here and provide the custom primitive data with the following correlation, like matte pattern 0 index, matte intensity index 10. So 0, 0, 1, 1, 2, 2. Like we can have up to 10 different ground materials applied over our car. So it's pretty much big variety, and yep. And the logic for applying overpaint is kind of simple. We simply lerp between each layers depending on the snow pattern, and each snow pattern has its own intensity. And that's it. Now let's talk about the blueprint logic. So first of all, let's create the variables and functions and then follow the flow. So we need to have the array of primitive component. It's our interactive meshes. Also need to have new pattern list. It's the array of integer, and new pattern list updated. Also the array of integer. We're going to use those arrays to have the pattern for the shader to be applied over our car. We have the delay before layer cleaning timer. It's the timer handler, just in case if you want to clear all the layers once you are not moving. We have the boolean should clear layer, also for the purpose of clearing data. We have the physical material layer current. We have the layer map. It's the map of the physical material and the integer. And here we need to define the map ourselves. It's like the predefined setup, not the dynamic one. So here we set the mud, puddle, snow elements with the following indexes. Layer intensity map defines with the integer and the float, and it's going to be dynamically updated. We have the layer index current, and the default value should be -1. So just for the sake of the logic, because once we start our game and we are already like tracing over some piece of landscape, we don't need to paint and call the logic until we move to the next layer. Layer index previous, also -1. Layer intensity current, it's the float. Layer intensity previous, also float. And the layer intensity buffer. So it's for the logic to change between our current and the previous layer. So that's how we can store one layer intensity and start painting with the new layer, but without overpainting the intensity of the previous layer, and so on. Now the functions. The pure function called is standing with the output of the boolean, just to define whether we are moving or not. Get trace offset with two outputs, both are vectors, So we're gonna use it here just for the pretty much clear look of our logic. It's the trace results. Get layer intensity index, also pure function with the input of the layer index and the output of the intensity index. Prepare a new pattern list, simple function without any inputs and outputs. The same way, generate new pattern. Next one is switch layer intensity. Next, layer update with the input of the boolean. It defines whether we need to clear our layer or not. And the function called clean mesh, where we need to provide the incoming mesh, it's the primitive component, and the cleaning speed. So rather we need to clean our vehicle and how fast this clean should happen. So the main graph. On the event begin play, from the get owner, I extract the components with a specific tag that we defined earlier. Here on our pawn, over the skeletal mesh, we have a tag called dynamic interaction. So I store those components as the interactive mesh array. You may see I have can execute cosmetic events. As I said, I use this in my day job and we have the multiplayer game. So that's the way that we define that the logic gonna be executed only on the client but not on the server. Next one, on a tick event, we check whether our owner is alive, and we have a sequence. The first one, depending whether we are standing or not, we need to call do once over the set timer by function name event. It means that once we stop moving, we need to, if we have the clear functionality, to change the boolean should clean layer to true. By default it's false. That's the only purpose to use this timer, and the time here can be changed. I said it earlier, but once we start moving, we need to reset the whole thing until we stop again. Next one we call stop layer cleaning, prepare new pattern list, and generate new pattern. The following flow. So it has conditions inside each function that we're gonna see further in this tutorial. And the last one is whether we are standing or not, like the same that we have here, but with different logic. If we're standing and depending on the should clear boolean, if it's true, we need to call a function called layer update and specify the clean layer input. But if it's false, if we are standing, if we are not standing, if we are like on a track, we are driving, we need to trace over our landscape. And as you can see, I use trace by channel and the channel's visibility. On the break hit result, we check whether we have the blocking hit, and we store the physical material as our current layer. Next we have the sequence, and here we check whether the current layer is inside the layer map that we defined earlier. And if it's so, and if it's not the current index, we store our layer index as our previous one and call switch layer intensity. If it's not, we just need to reset the do once logic and wait until we start driving over the next layer, because once we are over one layer, we don't need to overpaint it or switch layers every time, because this logic is on the tick, right? So that's why we need to have the do once here. Then we call layer update. Here we don't need to clear our layers, but we just need to like decrease or increase the intensity of our current and the previous layers. And we check our current layer, and if we find it, we need to set it as our current index every time. What else? The last one here in the main graph is the custom event called stop layer cleaning. We check whether we are not standing, and if it's so, we simply need to switch back our should clear layer boolean to false. Also, depending on this condition, we only need to do this once. So let's fill our functions. The first one called is standing, and here I get owner, I get its velocity. I use vector length xy because I don't need to apply anything while my vehicle is in the air. And I also use nearly equal with the high error tolerance because the car can have the inertia. So I need to cut those corner cases. Next, get trace offset. So from the owner I get its location and use it as the trace start. But for the trace end I need to subtract 1000 units from the z-axis. So the trace is going to be from the pivot point down to the ground. Next one, get layer intensity index. So based on the layer index, I need to return the layer intensity. So if it's from 0 to 2, I need to return the following that I have here in the selection node. For the 0 it's 10, for the 1 it's 11, for the 2 it's 12. The correlation that we have here for the vehicle base material. So, and if it's lower than 0, it means our car is on the default ground layer, so I don't need to update anything. I use the intensity index of -1. Next, prepare new pattern list. So I clear new pattern list. I iterate over the layer intensity key values. I find this index in the map, and if it's nearly 0, I need to like update the new pattern list with the new index. Next one, generate new pattern. So I iterate over all my meshes and over the all new pattern list array that we get right up here to actually make new patterns for each mesh for our shader for those values that we're going to use right up here. For this, we check whether intensity index is inside the new pattern list updated, and if it's not, it means the new pattern should be calculated. So I update set custom primitive data with a new random integer between 0 and 9, and the index is right up here. It's going to be used for the seed, this, and this. And on the complete, I need to store the new pattern list and the new pattern list updated. Next, switch layer intensity. So once we are driving over one layer, our current layer is, let's say, matte. But if we drive over the second one, our current layer should become the previous one, and the new one should become the current one. So that's why I use this logic. So we need to store the previous layer as the buffer, and we need to override our previous data with the new layer incoming. Next, we get our previous layer, which is now the buffer, and we use this value to override our current intensity layer. like this. Next one big function, layer update, that we use here on a tick, and also here in case we are clearing our layers. So I do have a lot of temporal variables just for the graph to be more cleaner. Based on the value that we have here, clean layer, we need to store the current target that we use here in the interpolation logic. We also need to define the current and previous speed cleaning layer, and we need to extract the intensity for the current and the previous layers. So next one, we need to update the current layer intensity, next one previous layer intensity, with the following math. And we need to update our maps with the new values. Next, we need to iterate of our meshes and update custom primitive data for the intensity, our intensity map, intensity values for the current and the previous layer. And if we are cleaning our layer, we need to execute the next function called clean mesh. So here I need to interpolate, I need to iterate over the intensity map keys, and it's for the situation like if our car is standing still, we need to clear all the layers, or if we are in between three layers, we need to clear the last layer, not the last, but we need to leave current and previous layers without any changes, but the third layer should be cleaned. So we store the array of intensity as the leftover index, and we check whether it's not the current, or it's not previous, or if it's higher than 0. Then we interpolate between the values. So we find the intensity map leftover index, and we update it with the value of 0, so it means we are clearing it with the cleaning speed that we have right up here from the input. And we update our map for our index, and we also update this index in the custom primitive data float using this custom primitive data float node. So guys, it's been tough after such a long break, but yep, that's it, that's the whole tutorial, and I hope you understand everything, and I'm really thankful for all of you who lasted from the beginning to the end of this tutorial. So as always, I have the Patreon page, and if you want to support monetarily, you can follow up the link under this video. Leave your feedback, subscribe to my channel, press like button, and share with your friends. And I see you next time, guys.